The first thing you want to do when you realize that the roots are 2 and 5 is understand that these roots actually reflect 2 points, 2, 0 and 5, 0. Now these roots would have come from a quadratic equation of the type y is equal to x minus 2, x minus 5. It's working your way backwards. This would give a root of 2 and a root of 5. Now we've come up with a way to do this for all different kinds of roots, especially when they're not whole numbers, not fractions, or not even real numbers. What we do is we take the sum of the two roots, sum of 5 and 2 would be 7, and we take the product, 5 times 2, 10. Then we have the equation y is equal to some a value, don't really care what it is, x squared minus the sum times x plus the product. This is just another way of FOILing if we had right here x minus 2, x minus 5. When you FOIL, the middle term is often the sum, and the last term is the product. So if we just look at these two values, we can get y is equal to a x squared minus the sum plus the product. Now, a could be any of infinitely many values, and the question just says find a quadratic with integer coefficients. So that a value could be 1, in which case we could just say y is equal to x squared minus 7x plus 10. That's one example. You could also make that a value be anything else you want, like maybe the number 3. 3x squared minus 21x plus 30. This is another example, and both of these would be perfectly acceptable answers. You could have infinitely many, as long as they have integer coefficients. This is the simplest one, so that's the one we're going to end up using. Let's do one more example, like number 13, where you have roots of 1 plus radical 3, and then 1 minus radical 3. And these would be your two roots. We do the sum, which means you add them. 1 plus 1, root 3 minus root 3, so that goes away. And then you do the product. It's a FOIL difference of two squares. So that times that is 1 minus root 3 times root 3 is 3, negative 2. Y is equal to... These won't always come out as opposites, no. X squared minus the sum plus the product, which would be minus 2, and there's quadratic.
And then, wait, what was the thing about changing it